So very often, you might be taking measurements within a lab and then you combine them mathematically in some way. So this combination of seeing how your precision changes is called the propagation of error. Now remember that error, or experimental error, doesn't mean you messed up or you made a mistake. Rather, it's a measurement of the precision. So 2.79 plus or minus 0.02, my error is 0.2 millimeters. And remember, I can write this just with a parenthesis, where the parentheses give me the uncertainty in that last digit. So let's say maybe I had a square that happened to have those measurements on both sides. If I want to get the area, well, that'd be simple enough, I guess. I'd multiply 2.79 times 2.79. Now, just using my calculator, I see I get 7.784100, so forth, centimeters squared. One shortcut, but also perhaps not as both clear or correct method, would be using significant figures, which for multiplication says round to the smallest number of significant figures. They both have 3, so in the end I would write down my answer as 7.78. Not adding those extra digits because that would indicate that I've measured something more precisely. If you work through the math using the propagation of error, it turns out you'd get 7.78, the same value, plus or minus 0.08. Now, there's a couple different ways to do this. First is you can do some math, which is a little bit heavy for what we're doing in this class right now, but the results aren't too bad, although I guess I'd rather add or subtract, maybe multiply, division, it gets a little bit harder. But you can basically get a recipe for what would you do if you combine two numbers. So in this case, as we multiply two values, a times b, whatever those values are, I would take the one of those values squared times the uncertainty in the other one squared, and then sum them to the first, a squared, times the uncertainty in the other, b squared, take the square root. When you do that, you'll end up getting just about, kind of rounding it to just one significant figure, 0.08. Now, more often we'll actually just have the computer do this for us. The downside is there's a little bit of the learning curve to get Python doing what you want it to, but the upside is the math of it basically can just do all of this behind the scenes. So it follows these recipes. Computers are great at following specific recipes. So this will allow us to do other mathematics very nicely. So just to kind of point to some of the syntax you'll be looking at in this lab, I assign values x and y to the value 2.79. The uncertainty is the next digit, 0.02. And I did that for both x and y. Then I use print to output x times y, and I get 7.78 plus or minus 0.08. Notice it automatically follows kind of the rules of the significant figures as well, but it gives us more information. It lets us know to a better degree our precision at which this measurement was taken.